Hello viewers, welcome to Usman Chayin Physics Maths class. In our tutorial today, I shall provide a solution to the problem before us. The question to read: the displacement of a particle S is given by the expression S is equal to A plus BT plus CT square. We are asked to deduce the dimension and the unit of the constant A, B, and C. So let's get started. So for us to get the dimension and the constant A, the first step here is we show that at open bracket T is equal to 0. We want to obtain the S. So what we're going to do, we substitute it into that very equation. S will be equal to A, then plus B into 0 plus C into 0 square. Now every here we're going to give us S is equal to A, and S is the displacement. All right, S is the displacement, and if S is equal to A, then A is equal to E. So hence we say the dimension of this displacement is what? Is capital L. Okay, and the dimension of the unit of S, or the unit of displacement, is equal to what? Meter. Hence we say the constant, the unit of the constant is meter, while the dimension is what? L. And that answers the first question, the constant A. Okay, so let's move to the second one. The second one is B. So what are we going to do? We have to differentiate the displacement. Now when you differentiate displacement, that is ds over dt, we are going to have velocity, and this will be equal to, this will be having what? B plus 2ct. Okay, that is exactly what we're going to have, because this is a constant. If you differentiate a constant, it will disappear. All right, so what we're going to do now, we said at t equals 0, when t is equal to 0, automatically the whole of this one will become 0. So v will be equal to b, and if v is what? The velocity, okay, or ds over dt is equal to velocity, and the velocity is equal to b, we will then ask what is the dimension of velocity, and the dimension of velocity is L t raised to power minus 1, comma, then what is the unit of this very velocity? The unit of velocity is meter per second, and this answer that very question. The constant b, the dimension is lt raised to power minus 1, while the unit is meter per second, and that is it for that. So we have to move to the third one, which is what? C. Okay, this C we have to what? Differentiate again. We have to differentiate velocity. We said dv over dt is equal to acceleration, isn't it so? Is equal to acceleration, and this can also be written as d square s all over dt square. Okay, and this will be equal to what? C. So let's apply it here. Let us apply it here. We said dv over dt is equal to acceleration. Okay, and that can also be written as d square s all over what? dt square. And if you differentiate it for a second time, you're going to have, okay, there's 2 here, we're going to have what? 2c. Now if acceleration a is equal to what? 2c, then what it means here is that a is equal to this. All right, so we need a dimension of what? A, and this 2 is what? Constant. Okay, so the dimension of a, that is the dimension of acceleration, the dimension of acceleration is L t raised to power minus 2, and the unit is meter per second square. And this is the solution of this very problem, that the dimension of A is L, and the unit of A is m. And the dimension of B is meter. The dimension of B is length, t raised to power minus 1, and the unit is meter per second. And the dimension of C is lt raised to power minus 2, then the unit is meter per second square. In case if this is your first time watching this very video, I encourage you to go to YouTube and subscribe to Usman Chayin Physics Maths Class. Follow Usman Chayin Physics Maths Class on Facebook, TikTok, and Instagram to enjoy all of his videos.